Okay, today we are going to be talking about some awesome, super duper cool vertical angles. Woo! Oh, hot dang. This is going to be fun. Alrighty. So what are vertical angles exactly? Well, sometimes you might see like a couple maybe intersecting streets or a couple boards that intersect or whatever in a construction type setting. In math, we're just talking about the two angles right here. These two bad boys are vertical angles. Okay, they're like opposite each other. Or these two are vertical angles. Notice the different markings that I gave them. So, the ones that are across from each other, what do we think we know about them? If you are thinking that they are congruent, you are absolutely correct. This angle right here and this angle across from it right here, those two vertical angles are congruent. These are also congruent. Alright, the pairs, not all four, but the pairs across from each other, the vertical angles are congruent. And that's the main thing that's really important about vertical angles, is that they are congruent. Okay, identifying them is one thing, but the theorem that all vertical angles are congruent, that's the powerful part, okay? And again, the pairs, these two are congruent, and these two are congruent. Cool? Alright, let's see where this might apply in a construction setting. So next time you're at like an old cabin, or even a new cabin made to look like, it's, cool and old and stuff, you might want to look up and see some roof trusses, okay? So these are, we'll talk about the name of them in class, but they'd be often called hip scissor trusses. Hopefully I'm correct on that, as I'm the math teacher. Okay. So we got some roof trusses here that look super cool. You might even see these out like in a park at a place, when they're building like a cool little structure to hang out at. The main thing that we're looking at here, if you haven't noticed it already, would be, boom. Whoop, that is terrible. That and that. Boom. Vertical angles. And you can see those all the way down in each set of trusses. Okay? So yeah, there you go. You got congruent angles. Now, how would that really be helpful? Like, oh, cool, I know that those guys are congruent. Big deal. Well, you know that you're making your cuts the same as you're putting these trusses together. Okay, they are symmetrical. That's something that's pretty powerful there. Although that the two vertical angles aren't necessarily super helpful. You know that those two are congruent. You know that what I'm looking at here is the angle at which these if you look closely at these, or maybe even at this one, you can see kind of like a little cut right there, right? To put them together, you know that those are going to be the same on each board. And those angles are, in fact, now we're getting crazy with it, those angles are going to be supplementary to these angles. And we know that these guys are congruent, right? Okay, so we got some supplementary angles going on with our angles that we're cutting it to make these trusses. We know those angles that are opposite each other are vertical angles, which means they are congruent. All right, so not too involved with the application on this one, but they are present in the construction world. America. So how would this look in like a math class, just in like pure math, not necessarily application based? Let's see here. Well, this would be a little bit of an algebra review. Let's go with saying that this angle measure right here is 2x plus 10. Okay, that'd be like degrees. Okay, but it's like algebra type. All right, you'll see that sometimes. And let's say we got 5x minus 2, and let's say the problem says find all four angles. How the heck are we going to do that? Well, what do we know about these two vertical angles? We do know that all vertical angles are congruent. So if they're all congruent, we can set these guys equal to each other. Woo! That's dope. All right, let's solve the equation. I'm going to subtract 2x and I'm to the other side, and I'm going to add 2. So plus 2 plus 2. I'm going to subtract 2x minus 2x. Okay? Now let's balance this all. We've got 12 on this side equals, because these guys cancel, right? This cancels. 5x minus 2x is 3x. How do I finish this out? Divide by 3. X equals 4. Woo, is that my final answer? Heck no. I got to plug it back in, yo. Okay, well, if I plug 4 in for x, let's do that over here. 2 parentheses 4 plus 10. I like to put my numbers in parentheses when I'm substituting back in. So 2 times 4 is 8, plus 10 is 18 degrees. All right. Well, if that's 18 degrees, the other one across from it should be as well. And if I just do a quick mental check, it is indeed 18 degrees. 5 times 4 is 20, minus 2 is 18. What does that mean about these other angles? What do we know about these guys? Well, take a look at this. Straight line. This whole thing is 180 degrees, right? These two angles are supplementary, meaning this 18 and this guy, or this 18 and this guy. Well, if they add up to 180, what am I going to get? Well, what's 180 minus 18? Nailed it. And I know that this guy's going to be the same by either doing supplementary angles or that they're vertical angles, the 162s. Cool, cool. America.